Alright, so in our last class we did conversion from binary uh, to octal and hexadecimal. So there you have it. This is the question before us. It says convert 88 base 10 to a number in base 2, base 5, octal and hexadecimal. Then question 2 says, but let's try to look at this first. Base 88 to base 2. So please, we need to be fast. So I have 88, and when I'm doing this, I'll make sure that anytime I'm converting from base 10 to say any n base, I will simply, be it base 8, base 10, base 20, base whatever. So first it's from base 10 I'm converting to. I'll simply do that value given to me in base 10. I'll divide it throughout till I get 0. Let's use that approach. So I'll say 2 into 88, I'll get 44, remainder 0. 2 into 44, I will get 22, remainder 0. 2 into 22, I will get 11, remainder 0. We could say let's divide this by 11, but let's progress with this pattern so that I have 2 into 11, that is 11 divided by 2. I'll get 5, remainder 1. 2 into 5, that is 5 divided by 2. I'll get 2, remainder 1. That is 2 times 2 plus 1. So 2 divided by 2, I'll get 1, remainder 0. 1 times. So 2 into 1, that is 2 divided by 1. You see that this will actually give me 0, remainder 1. That is what I mean by this is simply, remember, it's not 2 divided by 1, but rather 1 divided by 2. So I think it's best that way. So 1 divided by 2, I'll get 0, remainder 1. So if I know this, I will now get my answer. The answer I'm going to get is simply going to be by taking the remainders. And see the way we do it, we move up. This is what we call, this part where we have down, as we are going up now, we call this the MSB, the most significant bit. And this one we call it the least significant bit. So I'll write it to now be 1, 0, 1, 1, 0, 0, 0. You see it? So, and it's in base 2 that we're taking it to. So in base 2. So notice that 88 to base 10 is equals to this value. So remember, they also asked us to convert this to base 5. So trying to convert this to base 5, let's try and see what we have. So 88, let me get my, so 88 will divide. It's very simple if you just know that all you do is, if you are converting from base 10 to any base, divide by that value. 88 divided by 5, I have 17. In my calculator, I see 17.6. Now, what you do is just write the 17, then write a remainder. That 0.6 is the same thing as saying 0.6. That 0.6, use it and times the base you are having. Assuming what I have here is base 8, I'll use that 0.6 and times it. Here is base 5. I'll simply do 0.6 times 5. It is giving me 3. I write remainder 3. So I will go again. 17 divided by 5. It will give me, on my calculator, I will have 3.4. Write the whole number 3. Remainder That 0.4 is the same thing as saying 0.4 times the base, which is 5. So I'll do 0.4 times 5. It's giving me remainder 2. So I'll go again. If I do 3 divided by 5, I'll get 0.6. Yeah? At this junction, write 0. Remember we divide. At this point, write 0. Remainder. You got 0.6, which is the same thing you got here. You simply do 0.6 times 5 is going to give you 3. You have remainder 3. So this is the point where most students get confused. They're asking, how did he get the remainder? So the remainder is simply by, if you punch whatever you have, the fraction part, use it and be timesing what you are, the base you are converting to. So if you finish, you apply the principle, which is least significant bits, most significant bits. So this is going to be 3, 2, 3 in base 5. So it's 8 is 10 is equals to 3, 2, 3 in base 5. Let's try to look at what we have for octa. For octa, 88 for octa, which is base 8, is simply come and put 8 here. And I can very well see that if I have 88 divided by 8, yes, I have 11. So I'll have 11, remainder 0. I'll do again. 11 divided by 8. So 8 here. I have 1, remainder. I see on my calculator 1.375. That 0.375 is the same as saying 0.375. Just use it. Come and say this base, which is 8 times 0.375. I get 3, remainder 3. So I'll come again. 1 divided by 8. I'll get, okay, let's do it. I have 1 divided by 8. I get, it's supposed to have 0 remainder 8, but let's try to do it so that you see what we have. On the calculator, it will get 0.125. I'll just come and write the whole number part 0 remainder. This 0.125. This 0.125 is the same thing as saying 0.125 times 8. Times 8. So you see that I will get remainder 1. Are you seeing it? So if I do that, it's more like saying that it cannot go. That is why we get this. So whenever we get to this part, so that we don't have to be stressing ourselves, whenever we get to the part of 1 divided by 8 or 1 divided by anything, we will always do 0 remainder 1 to show that it did not go. So move up LSB, MSB. So this is going to be the same thing as saying 130 in base 8. So 88 in base 10 is equals to 130 in base 8. So let's try to do for base 16 now. Let's try to take this to base 16. Remember our question. So we've solved for base 2, base 5, base 8. This is base 16 now. So for base 16, we simply divide by 16 throughout. So let's go. We have 88 divided by 16. We have 5.5. We have 5.5. So just write the whole number part. 5 remainder 0.5. 5.5. 0.5 is the same as 0.5. So 0.5 times 16, you get 8, remainder 8. So we go again. 5, this 5 divided by 16. Divided by 16. We get, on the calculator, we get 0.3125. Just write the whole part, 0, remainder. That's 0.31325 is the same as saying 0.3125 times 16. So it's going to give me 5. Remainder 5. So the minute you get 0, you stop. So do the same thing. LSB, least significant bit, most significant bit. You see that this is going to give you the same thing as saying 88 in base 10 is equals to 58 in base 16. Alright. So let's try to solve the second question. I will need to be fast. So the second question we have here says, convert the following to decimal. 421 base 5. And we should convert 421 base 5 to decimal. So converting 4215 to decimal is the same thing as saying taking 421 that is in base 5 and taking it to base 10. Decimal is base 10. Remember, octa base 8, binary base 2, hexadecimal base 16. This one is 0 to 7. This one is 0 to 1. You cannot have anything above that. This one is 0 to 15. And from 10 to 15, you represent it with A, B, C, D, E. So 0 to 9, then 10 to 15 this way. So if I know this, it simply means that you need to know that anytime you are converting from any base at all, once you are converting from any base at all to base 10, simply multiply the base. Multiply that base that you are converting to by its power. Multiply by its power and the value before it. So multiply the base, or you say raise the base to the power, then multiply by the value, each value before it, then add up. See what I mean? This 421 is simply the same thing as saying to convert it to base 10. So anytime you're moving from any base to base 10, simply, for example, this one, I will bring out 4. I'll bring out my 2. I'll bring out my 1. Notice that it is in base 5. Shebi? So I'll say raised to power 0, raised to power 1, raised to power 2. I start from back and move. So if I do this, this is going to be the same thing as saying, I've gotten this value, this value, this value. The basis is 5, right? So come and multiply by the base. So multiply each one by the base, which is 5. That power that you got is for the base. So times 5 for the base times 5. And this one is 0, 1, 2 for the base. So by the time you do this, you see that you are left with, excuse me. So I have 5 raised to power 0 is 1. 1 times 1 is 1. So plus, I separate this with plus, 5 raised to power 1 is 5. 5 times 2. 5 times 2 is 10 plus 1 plus, this is 25 times 4. This is 100. So by the time you do this, you have 100 plus 10 plus 11, you have 111 is 10. That is your answer.